Okay. So welcome La Scuola families and prospective La Scuola families and some of our faculty who are here tonight. Buonasera e benvenuti. We are so glad to see you, especially given the couple of weeks we've been dealing with in these 2 weeks in January. La Scuola is in its 9th year as an elementary school. And as we reached our 4th year, and after exploring math curricula, we piloted Singapore math. La Scuola is an international baccalaureate school where inquiry is central, and we follow the Reggio approach, holding this high image of a child, and we know children have 100 languages. Singapore math is also inquiry-based and reflects a high image of the child. It provides a 360-degree view of a math concept, thus offering many entry points for a child to participate and develop a conceptual understanding. Shortly into our Singapore math implementation 4 years ago, we met the wonderful Beth Curran, who is our guest tonight. Beth has led our faculty during August professional development and also at mid-year check-ins. And we have thrived with her guidance. Before I turn things over to Beth, I just want to let you know that I will be seeing, feel free to put any questions into the chat. I will be taking them in, keeping a close eye on them. And most likely we will address all your questions to the extent possible, and I imagine all of them, and likely by the end of the presentation. So we'll just figure out when's the best time to chime in. So just rest assured, and if you have any timing issues, also let me know in the chat. So we'll definitely address them. So please have them, send them our way. And I also just one final note, in addition to this wonderful evening tonight that we've been doing for, I think this is our 3rd or 4th year, we had it in person. It was a standing room only when we were in person pre-COVID. So we're so glad, again, that you are here this evening. In addition to the parent education evening tonight, we have what's called a spotlight series. So midday next Friday, a few faculty will be joining me, and we will be talking about learning through Singapore math at La Scuola, and you'll be seeing examples of classroom work, and you'll be in dialogue with the teachers. So that's another great event that explains and immerses you more into Singapore math. So with that, I'd love to welcome again Beth Curran, and thank you for being here.
Oh, thank you so much for having me. And I do just want to take a moment to thank all of you for taking some time out of your busy schedules to, share an hour with me so that I can share with you something that I'm incredibly passionate about, which is improving math education in the United States. So just to give you a little brief history about me and kind of my story and how I ended up here. I always felt like I was a really good math student myself. Went through high levels of math in college and then, began teaching. And it wasn't until I had a student who was really confused with a relatively simple concept, subtracting across zeros and how do you rename those numbers? And I couldn't explain it to him because I had memorized the procedure and I didn't understand how come you cross off some of those zeros and they become 9s and some of the zeros become a 10. And so it really, at that point, I realized, you know what, I owe my students better. And so that was when I was introduced to a Singapore curriculum shortly after that. And immediately I was converted. It's like, this is the way that math should be taught. Being that math person and being excited about math, I was, doubly excited about learning how to now break apart math in a way that made sense to my students. And so super excited. And I am excited to share that with you. And I thank you all for joining me tonight. I'm going to go ahead and share my screen. And let's get this going here. All right, so just thumbs up, we can see the presentation here. Okay, very good. Okay, so again, thank you for coming here tonight. Here's my contact information. I do believe that Sally emailed out, La Scuola emailed out also kind of a handout sheet that has all this information on it as well. So if you didn't have a chance to open that up or to print that out, just know that a lot of the information I'll be talking about tonight is in that handout. And so you don't feel like you have to write a bunch of things down. My contact information is there. I am happy to answer any questions that you might have about Singapore math in general, but any specific questions about your child or their classroom or the school probably are best directed towards Sally. Okay, so here's what we're going to go over tonight. Why is La Scuola using primary mathematics? We're going to talk a little bit about what we know about how children learn best. I'll give you a chance to explore some of the content and to experience some of the methodologies that go along with the Singapore math approach. We'll discuss a little bit about how you can help at home and then reserve some time for some questions and answers. That being said, if you have questions throughout, Sally did say, feel free to type those in the chat. She's going to be monitoring that for me. So, she'll determine whether or not it's appropriate to kind of interrupt if it's a very timely question, or maybe just to hold on to all those questions and come back to those at the end. So please don't hesitate to type anything in that chat box. And so with that being said, we'll just go ahead and move on here. Okay, so to understand Singapore math, you kind of have to understand a little bit about Singapore. So this is the Singapore that we know today. But I will tell you, just about a generation ago, a lot of people would have considered Singapore a third world country. They had found themselves in a situation where they had been, they gained their independence, which sounds lovely, right? But essentially they were kicked out of Malaysia because they were such an economic burden. It's a small island country. They have no natural resources. In fact, they were having to buy water and sand from nearby countries. So at that point, when they gained their independence, they decided that they needed to do something in order to build their own economy. And they thought, well, our biggest resource is our people. And the best way to invest in that resource is to invest in your education system. And so, I guess it was around the early 70s and 80s, they started really working on their education system and focusing on how they were going to teach reading and how they were going to teach mathematics. And out of that came their national curriculum for mathematics. So that's what the Singapore, when you hear Singapore math, that's what that's based on. So a lot of that, the methodologies that we now use today, grew out of that. So between the early 80s and 1995, when Singapore's students participated in an international test, they went from scoring probably about 200 below the average or the mean on this international test to scoring in the #1 position. So they had gained, nearly 300 points within just that short amount of time, about 15 years of actually fine-tuning their mathematics curriculum. Their students ranked at the top of the world on that 1995 Trends in Math and Science Study test, which we'll dig into a little bit deeper in just a moment here. But what's even more amazing is that they have remained in that top ever since. So we have over 20 years now of data that shows that whatever Singapore was doing with their students and their curriculum works, and it continues to work, and their scores continue to improve. In the 1980s, when they were writing their curriculum for mathematics and reading, they also decided to teach in English because it's a big melting pot of lots of different cultures there in Singapore. And they decided that, everyone should learn English. So again, why do we see Singapore math in the United States? Because it was super easy to bring those materials over because they were already in English. We didn't have to translate them. And primary mathematics, which is the curriculum that La Scuola uses, has been used in the United States for nearly 2 decades, over 2 decades now when it came in. So that's the original curriculum that Singapore based their success off of. Okay, so let's dig into this Trends in Math and Science study just a little bit. So these are the most recent scores from the most recent test, which was actually in 2019. And you can see there again, Singapore's students, this is 4th grade, ranking at the top with a scale score of 625. Now, I also circled the United States there. Our scale score on that test was 535. So not a bad score, but 90 points below Singapore, 90 points below the top. And we would just think that our students should be able to do a little bit better than that. So what I want you to do is take a look at the top 5 scoring countries there. I underlined 4 of them in blue. So there's definitely some similarities there. They're all those Eastern Asian countries. So again, why aren't we teaching Korean math or Chinese math or Japanese math here in the United States? Because the Singapore math materials were already in English, but they all have a similar focus on problem solving, and they all have a similar focus on teaching math conceptually. So that's why they're kind of, far and away above. If you look at the difference between Japan's score and the Russian Federation, there's quite a gap there between those top scoring countries and then everybody else. Now, for me, as a curriculum person, what I get super excited about is when I see data like this. So yeah, the scale score, that's great. But when you dig into the type of questioning that's on this Trends in Math and Science study, I think this is where it really becomes clear as to what our traditional curriculum in the United States is lacking in. So there are 4 benchmark types of questions on this Trends in Math and Science study. So a low-level question, which would be considered kind of your basic computation. Intermediate, now we're talking about basic computation with very simple problem solving. A high-level question, now we're moving into maybe a little bit more complex problem solving. And then an advanced level question, those are novel questions. Those are unfamiliar problem solving. So things that students haven't been exposed to before, but it really tests whether or not they can take their understanding of concepts and apply that in an unfamiliar situation. And so here you see, this again is 4th grade data. In blue is the percentage of students who could answer these types of questions in Singapore, and then in red in the United States. So what you see here is with those low-level basic computation questions, we're doing pretty well, keeping up with those students in Singapore. As the question type gets harder though, what you see here is the gap gets wider and wider and wider. And so what that says is our traditional mathematics in the United States has done a really good job of teaching students to calculate, but has not done a very good job of teaching them to problem solve, to apply that calculation to solving problems. And if we think about it, what really is real life application of mathematics is all about problem solving. I don't think any of you can say that you go to work and you are solving routine problems over and over and over again. It's always something new. It's always something unexpected. And so that problem solving really does need to be at the heart of the curriculum. Okay, so here's some examples of some of these types of questions. So this would be considered a low-level 4th grade question. 3 plus 8 is equal to something plus 6. So what we want is for students to recognize the value of that equals sign. So what does it mean to have 3 plus 8? Well, it means that the value of that expression on one side of that equal sign has to equal the value of the expression on the other side in order for that to be an equation and for it to be balanced. So in the United States, a lot of students will look at that 3 plus 8 equals blank, and they'll put an 11 in there because they have been taught that anything beyond the equal sign is the answer. So 3 plus 8 is the answer would come next. And so the plus 6 would confuse a lot of students, believe it or not. Only 47% of students in the United States in 4th grade could answer this correctly. So hopefully that's a little bit shocking to you. So what we want is for students to recognize that, again, the equal sign means that the expression on one side has to balance with the expression on the other. So 11 is equal to what plus 6? Okay, so we can see there that 5 would complete that. This would be an example of an intermediate type 4th grade question. Tom ate half of a cake and Jane ate 1/4 of the cake. How much cake did they eat all together? Now I chose this one because I wanted you to take a look closely at the student response here. So does anybody recognize this? Let me see if I can get my pen going here. Hold on 1 second. Anybody recognize this? The butterfly method, right? Okay, so this student clearly remembered that there had something to do with circling these numbers and making it look like a butterfly, but no idea really what to do to solve this problem. Now, with the Singapore approach, we do focus on teaching math conceptually. We teach students to visualize problem solving, and a bar model is a big part of that. And the bar model and fractions, a beautiful marriage. So Tom ate half of a cake. So this would represent the whole cake. Tom ate half of it, so we're going to section that off and we're going to label that with Tom. Now we know that Jane ate 1/4 of that same cake. So what we need to do now is divide it into 4 equal parts, and then we can label the part that Jane ate. Now at this point, do you even need to do any calculation to solve the problem? If we can teach students to visualize problem solving and to have a tool like bar modeling to be able to access problems like this, if they forget the calculation part, they still have a way into the problem. They have access to a problem like this. So rather than just teaching procedure for the sake of procedure, we really want students to have that deeper understanding of the mathematics that they're doing. So what we can see here is that altogether, they ate 3/4 of the cake. Okay, only 35% of students in the United States could answer this correctly, compared to 84% in Singapore. Okay. This would be more of a high level question. Duncan first traveled 4 8/10 kilometers in a car, and then he traveled 1 5/10 kilometers in a bus. How far did Duncan travel? So, in order to figure this out, he traveled in a car, he traveled in a bus, we just add them together. So it's not a complicated problem. This is a 74% United States problem. I will tell you that of the 26% of United States students that answered this incorrectly, they chose C. So what that tells us is we don't emphasize place value enough in education, in our traditional mathematics education in the United States. Again, if we're visualizing this situation with a bar model, we can see that this red bar represents the entire amount that Duncan traveled. We know that part of that was in the car, the other part was in the bus. And so again, all we have to do is add those together to come up with the answer of 6 3/10 kilometers. Okay. So Singapore put mathematical problem solving right at the heart of their curriculum. So it's right here, right in the middle. And they determined that all of these other components have to work together in order to create that strong mathematical problem solver. So we have to teach skills. So we do have to teach students how to do math. We have to teach them some procedures, but those skills have to go along with that conceptual understanding. Being able to visualize the mathematics is a really important part. The processes. So we want students to think about how they are approaching solving problems. So that would be their heuristics, different ways that they might solve problems. Maybe they will draw a bar model. Maybe they'll guess and check. Maybe they'll work backwards. Maybe they'll chart something out. So all of those processes are important as well. Metacognition is something that is more, I would say it lends itself more to teaching practices in the classroom. What we want is for students to recognize what is going on in their head as they're solving a problem. I work with a lot of teachers, and one thing that almost every teacher can relate to is that student who raises their hand and says, I know the answer is 13. And you say to that student, okay, how do you know it's 13? And they say, it just popped in my head. Right? So what we want is for the students to start really breaking down what went on in their head so that they recognize the process that they went through to get the answer, so that when the math gets harder, they can then generalize that process. They can apply that understanding of the mathematics in a higher, more complicated, more complex way. And so you'll hear in the classrooms a lot of talk around math, asking students to explain their thinking to each other, to the teacher, breaking things apart in different ways, lots of questioning of students, getting them to really think more deeply about how they're thinking through math. And then attitudes, that's kind of an interesting one there that is in this little pentagon here, but there's no lessons on perseverance in the curriculum, but what I can tell you from experience is that if students have a strong understanding of the concepts, They know how to do the math, so they have developed their skills. They have ways into problems through their processes, and they can think through their problems. They persevere through challenging problems because they have a place to start. And they know that by applying their understanding that they'll be able to work through things. So their attitudes just kind of naturally come along. So one thing that I want to just remind you as parents is that, quite often as children and learners, we think that this is what we need to be showing everybody all the time, is that success, the top of the iceberg, that's what we want people to see. But I would encourage you to remind your children that, that success comes from that perseverance and from failing and from being disappointed that maybe you didn't get the answer right the first time. And it comes from a lot of hard work and dedication and going back and trying and trying and trying again. And that with all of that's the part of the iceberg that's under the water that we don't see, then that success will happen. And so, we're not expecting them to be successful the first time that they look at something, but that it's going to take all of that really hard work underneath to get to that point where we see that. Okay, so when Singapore was developing their curriculum, they didn't reinvent the wheel. They took best practices from all around the world from educational psychologists and theorists, and they put all of that theory into action into their curriculum. They even took best practices from other disciplines and put that into action as well. So here's an example of what we know about how children learn language. And I think you guys can all relate to this. Having children, right? They were all babies at one time. And as we know, children tend to put everything in their mouth, or they want to touch everything that's in their world. And the whole time we're saying to them, this baby here, we might be saying, hey, that's an apple. That's a red apple. It's a crunchy, juicy red apple. So they're learning all this really rich language as they are experiencing and touching and tasting that apple. So that then when they come across an apple in a picture, in a book, they know exactly what that is because they've touched it, they've felt it, they've experienced it. And then we teach them APPLE means apple. It's the same apple in the book, and it's the same one that you held in your hand. And so that's what we call that concrete pictorial abstract progression. With math, though, we tend to want to start here. So with what Singapore did was they took that best practice from language and they said, no, we need to start concretely. We need to put objects in students' hands. If we're trying to get students to recognize the number 8, then we're going to give them 8 beads and we're going to let them count them. If we want them to understand how to add, we're going to give them 3 red beads and 5 blue beads. And we're going to ask them to push them together, pull them apart, see how many different ways we can make 8. So we want them starting off very concretely, touching and feeling the math. So that then when they see this represented in pictorial form, which might be a bar model, it might be a picture of strawberries and blueberries, ladybugs and beetles, whatever it might be, they now can relate to that because they have touched it and felt it. So they understand what that means and what that feels like. And then we need to move them to the abstract. So that's then when we introduce the numbers and the symbols that go along with math. So following that concrete pictorial abstract progression, is one of the hallmarks of the Singapore methodology in the curriculum. So what does this look like in higher levels? So what we want is for students to follow that progression so that they can derive meaning, so that they can come up with formulas on their own. A good example of this would be when we're teaching students about area. We might give them square tiles. Each square represents a unit, a square unit, right? And so we're giving them a bunch of tiles, we're asking them to build a rectangle, and then we're going to ask them how many of those square units cover that surface. And, in the beginning, students might count every single tile. And then quickly they'll start to recognize, well, wait a second, there's 5 across the top and there's 4 across the bottom. That looks just like a multiplication array. So every time that I have this array, I can just multiply 5 times 4 and I know there's going to be 20 there. And they start noticing that pattern. If I rearrange this, I can still multiply the length by the width and get the total number within there if I'm building a rectangle. So once they've reached that point, then we can move into a more abstract picture. So here we have the pictorial phase where we just have a rectangle. And where the students are told that there's the length of one side is 4 units and the width might be 5 units. And then to find the total number of square units, we would just multiply them. From that, then we ask students to derive the formula on their own. So how do we find area? Oh, we can always just multiply length times width. And so rather than starting with, we're going to find area, students, we multiply length times width, and then moving in the opposite direction, we're going to have them really start by building that first and coming up with that formula on their own. And why is that important? Well, because as we all know, having gone through high school math ourselves, there's a lot of formulas to memorize. And so having that conceptual understanding will be there to support you if you forget the formula, right? Students would have a place to go back to be able to work their way back up to solving a problem. So again, it provides access to the mathematics, even when maybe they forget some of those formulas. It also helps students to make sense of procedures. So this is a good one, right? 4/5 divided by 2, or imagine 4/5 divided by 3/4, right? We were told just invert and multiply. So again, we want students to work through this, starting at a very concrete level so that they see where this comes from. Why do we say invert and multiply, and why does that work? Well, this problem actually came out of a word problem where two friends were sharing 4/5 of a cake. And we want to know how much of the cake, what fraction of the cake each friend received. And so we might give students strips, square or rectangles of paper that represents the cake, and then they can fold and they can shade. And you can see here two different representations of how maybe a student would show what 4/5 divided by 2 would look like. And so what we're noticing is that what we're finding is 1/2 of 4/5, which then we can relate to 1/2 times 4/5. So if you look at this now, go back to our original problem here, 4/5 divided by 2. Well, what did we do? We took our 4/5 and we said we're going to multiply it by 1/2. And so that's how we get to that invert and multiply. And that's why it works. And students will spend lots of time with fractions and these calculations around fractions, folding paper and shading in things, and so that they really can visualize these procedures that go along with a lot of the operations around fractions. Okay, so even when students are learning to do traditional algorithms, we start very concretely. So here's an example, 32 times 3. We might just give students that problem and then ask them to build it. So here's a place value chart. We're not using place value manipulatives here, but we're using linking cubes. So the orange linking cubes are our 10s and the blue linking cubes are our 1s. We've built 32 with 3 10s and 2 1s, and then we repeated it 3 times. And so then students can see, okay, well, 2 1s times 3 is 6 1s altogether, and 3 10s times 3 is 9 10s or 90. And so then they start recognizing how to start using that traditional algorithm. They might then see this in pictorial form. So here are the place value discs that a lot of students will start using from about second grade on up using primary mathematics. And so here's a picture representing kind of what they already built there concretely. And then we move them into the abstract again. So the goal ultimately is to get them to the abstract, but we want to get them there with that deep understanding around those traditional algorithms. So here's some ideas of some things if you want to build up your own concrete math toolkit at home, just some great ideas. Jars of coins, those are great manipulatives. You can use the pennies and the dimes and maybe even some dollar bills as place value manipulatives. They're great counters. Buttons, if you have collections of buttons, or maybe your child has some collections of objects from nature, shells or pebbles or things like that. Anything that students can count. Maybe put those in a box and start building your own math manipulative kit at home. For place value, Skittles, M&Ms, Fruit Loops, anything that has color to it, where we can say, maybe the orange Skittles in this case were 1s and the purple Skittles are 10s. Or, if you're thinking about Fruit Loops, you've got different colors of Fruit Loops and you can divide those up. Different pasta shapes can represent different places within a place value chart. And then even we have some poker chips here that could also be used for place value to help solidify that understanding of our base 10 system for students. For problem solving with bar modeling, a great concrete manipulative are just strips of paper. Just have, paper strips cut out and handy. Post-it notes are great bar models for equal sized units. So those are wonderful manipulatives to have available to your child as they're working their way through this bar modeling and problem solving within the curriculum. There are also lots of online manipulatives, and Sally, I don't know if you guys at La Scuola have a specific online manipulative tool that you recommend. This is a great one, and the link to it, I believe, is in the handout. But let me just show you this here. So it's called Didax Virtual Manipulatives. And so I just recorded this, so I didn't have to go online. So you can see all of these are manipulatives. You can click on them, open them up. So here is place value. So there's place value chart, and there's our discs, and we can just click and drag. And so you have access to this. It's free. So that's what I love about Didax. And there are just lots of different manipulatives back on that home page there that we could look at. So if I start this over again, you can see all of them here. There's Unifix cubes, 10 frames, base 10 blocks, color tiles, like when we were doing the area, different color discs. So there's a lot of options on here that are just great manipulatives. Dice. So the dice are really fun to play around with. Spinners, pattern blocks, you name it, it's on there. So that's a great resource also. So let me talk a little bit about the coherent sequence within the curriculum. So it's a mastery-based curriculum, meaning that students will master the basics, the foundation, and then each year as they progress through the curriculum, they'll apply that basic understanding to a slightly more challenging situation. So a good way to explain this would be to take a look at the multiplication and division sequence. So we'll focus mostly on multiplication here. So in first grade, students are introduced to the idea of multiplication as being equal groups, repeating equal groups. So for example, here we've got 3 trains on a track and there's 4 train tracks. How many trains altogether? And so students will be building this. They'll be creating these equal groups and realizing that 3 multiplied by 4, or 4 groups of 3, is leading into that multiplication and that language around that. So it's very concrete, it's very conceptual. We're not expecting students to be memorizing any basic facts at this point, but just developing that conceptual understanding of what multiplication means and that connection to multiplication and repeated addition. Then in second grade, students take that basic understanding and they first start practicing multiplication with multiplying by 2 and 5 and 10. And those are chosen specifically because those are numbers that they've been skip counting by since kindergarten, maybe even preschool. So once they understand how to multiply by 2 and 5 and 10, then they use those basic facts to derive the other facts. So they work then on 3 and 4 using a 2's fact to help with a 3's fact, or like in this example here, if we know 2 times 3 is 6 and 2 times 3 is 6, well now 2 groups of 3 and 2 groups of 3 together is 4 groups of 3. So they can use that 2's fact to help them with the 4's fact. And so we want students to make connections between the math in that way. So then hopefully by the end of the second grade year, they are fluent in multiplying by 1, 2, 3, 4, 5, and 10. And then that gives them a real solid foundation for moving into third grade. In third grade, they're going to be introduced to the double digit by single digit traditional algorithm for multiplication using the 2's and the 3's and the 4's and the 5's, those facts that they're comfortable with so that they can really take in this new traditional algorithm. So you can see here applying the understanding of place value. So we can say here with 34 times 2, we're going to take our 4 1's and multiply it by 2, and that's 8. And then we've got 3 10's. We're going to multiply that by 2, and that's 6 10's or 60. Here you can see this traditional algorithm is kind of stretched out a little bit. It's what we call partial products. And then we can get to a point where we more efficiently write this. And then let me just back up a second. So then in third grade, after they've been introduced to this traditional algorithm, then they'll be introduced to strategies for multiplying by 6, 7, 8, and 9. And then they'll continue to practice this traditional algorithm for multiplication using those facts as they're developing fluency in 6, 7, 8, and 9. Then when they get into 4th grade, now we're seeing double digit by a multiple of 10. So we're leading into double digit by double digit multiplication, but focusing on that multiple of 10. So again, if we can multiply 34 times 2, then we can multiply 34 times 20 if we think of it as 34 times 2 tens. And then in 5th grade, they move on to multi-digit by multi-digit multiplication. And so by the time they get to 5th grade, they've got this traditional algorithm down. They know what to do. They've got the procedure, but they've also got all of that rich understanding around mathematics that goes with it. Number sense, developing number sense is a huge part of a Singapore style curriculum. And this number bond, which is this part whole model that you see here, is one of the big consistent models for helping students develop this relationship between numbers so that students learn that numbers can be broken apart into parts and the parts can be put together to create that number or that whole. It's a consistent model for decomposition and it's used throughout the grades, but it's introduced at a very simple with very simple numbers. So in kindergarten, students will be working with number bonds, putting together numbers and taking apart numbers up through 10. So in this case, we've got a 4 and a 6 in the parts, and students learn if they put the parts together, it makes the whole, and they connect that then to addition. 4 plus 6 is 10. So we can see we can use this number bond for addition. If we have the whole in one of the parts, students learn that they can then subtract to find the other part. And so they're creating this relationship between number. So rather than memorizing a whole bunch of basic facts for addition and subtraction, they really just need to learn how numbers can be broken apart and put together and the relationship between them. And this number bond is really helpful for that. So it's used throughout the grades though. So it's a consistent model. So even when students get to, I don't know, this might be a 4th grade, maybe even 3rd grade level problem, 2 1/4 plus 3 3/4. If you think back to procedure, how we learned how to do this, you might right now be thinking, oh, I'm going to have to put them all into an improper fraction. And then if they don't have the common denominator, I would find that and then convert everything back into a mixed number. What we want is for students to develop that number sense, even around fractions, and to recognize that, well, 3 3/4 is almost a whole. It just needs another 4th. And I can get the 4th from the 2 1/4 if I just break it apart. So we're breaking apart the 2 1/4 into 2 1/4. And then we can combine the 1/4 with the 3 3/4 to create 4. And so then the answer becomes 6. So we want students to get to be flexible in their thinking around calculating. Even when adding compound units of measurement, we have 1 liter, 250 milliliters minus 700 milliliters. Rather than converting everything into milliliters and then subtracting and converting back, again, what we want is for students to see, how can I break this apart to make the calculation easier? So maybe I want to subtract the 700 milliliters from that liter because I know that 1 liter is 1,000 milliliters, and that's an easy calculation to do in my head, right? So now I have 250 milliliters and 1,000 minus 700, which would be 300. And so then I put the 300 milliliters and the 250 together to get 550 milliliters. So again, that flexibility and thinking around calculating. Multiple strategies are going to be explored within the classroom. So students will have lots of access points into the math. So here's where we start. Now, I put this up here, this horizontal equation, because this is something that I hear from parents that it drives them crazy because maybe the workbook comes home and all of the problems are horizontal and there's no room for us to stack the numbers on top of each other. Well, it's by design because when we write equations horizontally, it really gets students to focus on the numbers and the value of the numbers. So for example, if I had given this to you in this format, right away, if I had said, solve this problem for me, you'd start adding your 6 and your 8s and get 14 and regroup and do a procedure, right? You might not even recognize that 98 is a number that's really close to 100. And that knowing that, then maybe there's other strategies that you could use that might be a little bit more efficient to solve it. And so we start here and we focus on that number sense and we talk about different strategies and ways that we can compose and decompose those numbers so that then we can get here with efficiency. If that truly is the most efficient strategy to use to solve that problem. So all of the mental math strategies that your students are being exposed to in class are helping to develop their number sense. It's helping them to see other ways of solving problems and developing their flexibility and thinking around numbers. So in order for students to be able to take in all these mental math strategies, they do have to have some basic facts under their belt. And so here's a fun way to practice some basic facts. It's one of my favorite games. It's called rock, paper, scissors, math. So you guys are probably familiar with rock, paper, scissors, where students would say, you know, rock, paper, scissors, shoot, and then they shoot out either paper or scissors or a rock. Well, this is kind of like that, except when we say, instead of saying shoot, we're going to say math and we're going to hold up some fingers. So it kind of goes like this. Okay, so students have their fists and they say rock, paper, scissors, math. And then you can play this with addition, you can play it with multiplication. So in this case, if we were adding, then whoever said 7 first, because we're adding the 5 fingers and the 2 fingers, would win the round. You could play this with multiplication where we could multiply. So 5 times 2, whoever says 10 first, that product first, then would win. So this is a great game. You know, you're standing in line, your child's getting a little wiggly and you want to just practice. You don't need any materials, just your hands, and you can play rock, paper, scissors, math. We'll talk about some benchmarks for basic fact fluency a little bit later in the presentation. But in order to start taking in the mental math strategies that are introduced in first grade, students do need to know how to add and subtract within 10. They need to know what makes 10 because the make 10 strategy is one of the first ones that comes up in first grade. So here's the make 10 strategy. Again, you can see starts off very concretely. So students would be given a 10 frame. Here you can see 2 10 frames. So it's basically just a frame that has 10 empty squares in it. And then we know that when it's filled with 10. And so that becomes that sort of base 10 sort of idea for students. So we would have them build 9 on one 10 frame, 4 on the other, and then pause and say, well, what do you notice? Right? Most students will say, well, the 10 frame with 9 on it only needs 1 more and it would be a complete 10 frame. So we teach them that they can take from that 4 and they can give to that 9. And so now the equation becomes 10 and 3 or 13. And so at first, you know, we're building this, we're moving discs around. It's not natural, but eventually we get to a point where we can just look at the 9 and the 4 and we can say, okay, I know that if I take 1 away from that 4 and I give it to the 9, I've created 10. And then what was left is 3, and then I put the 10 and the 3 together. And so it becomes more natural. Students start seeing this breaking apart of numbers in their head, and it becomes a mental math strategy that they can apply. We want students to develop flexibility in their thinking with these strategies. So a problem like 7 plus 8, both of those numbers are pretty close to 10. So you know what? I could break apart the 8, take the 3 and put it with a 7 to make 10. And now I have 10 and 5 or 15. Or the 8 being a little bit closer to 10, maybe I want to take the 2 away from the 7, give it to the 8 to make 10. And again, I have 5 and 10, which is 15. So we want them to be flexible. We want them to get creative in their thinking with solving these problems. We also want them to generalize. So now we're moving into 27 plus 8 would be end of year first grade strategy, and then moving into 127 and 38 might be moving into second grade. But we want them to generalize. If I can make 10 with 7 and 8, I can make a 10 with 27 and 8. I maybe take the 2 to complete the 8. Now I have 25 and 10 or 35. We could also go in the opposite direction. 27 only needs 3 more to make it 30, and I can take that 3 away from the 8. 127 and 38, same thing. 38 is only 2 away from 40, which is a nice even 10. So now I've got 125 and 40, which is 165. Easy calculation to do in my head. So we want students to come up with those nice friendly tens or hundreds so that it makes the calculation easier for them. Moving into even greater numbers than that. If we can make 10, we can make the next 100. So here, these numbers, what you're noticing hopefully is that 298 is really close to 300. And so there's a few strategies that we could do for this. We could take the 2 from the 542, give it to the 298. So now in our head, we're thinking 540 plus 300. Or what a lot of students will go to at this point is they do something called over adding, where they might look at 298 and say, well, it's close to 300. I'll just add 300 and then take 2 away because I over added by 2. So again, developing that flexibility and thinking around number. If we can do that, we can do numbers like this, right? We can make the next 1,000. It goes on and on and on, right? We also want students to be flexible in their thinking around multiplication and division. So in 3rd grade, students are introduced to strategies for decomposing numbers in order to multiply. So when I'm multiplying 24 times 3, students would recognize that 24 is made up of 20 and 4. And so I can multiply my 20 times 3 and get 60, and then my 4 times 3 and get 12. And again, that becomes our partial products. 60 and 12, then I put that together to get a total product of 72. Students might also recognize that 24 is close to 25, and that 25 times 3 being 75, maybe if they're familiar with coins and quarters. But then also recognizing, how do I now adjust my answer? Well, I wanted 24 groups of 3, but I went ahead and found 25 groups of 3. So now I have to take away a group of 3. So 75 minus the 3 would give me the 72. So encouraging, again, that flexibility in thinking, asking students to come up with multiple strategies for solving things to really help them develop their number sense around all of these operations. With division, we also teach students this. Sally, this actually is a picture, I think, from La Scuola.
It does look familiar.
Yeah. We teach students to decompose numbers when they're dividing. So with 56 divided by 4, what we're looking for are multiples of 4 that we know are hidden inside 56. And then knowing that, like, for example, if I know 4 times 10 is 40, I'm going to look and see if there's a 40 inside 56. There is. And then the other part would be the 16. And so now I've taken that 56 and I've broken it down into 2 basic facts so that now I have access into this problem. So for students who struggle with that long division algorithm, this gives them another way into division. So using those partial quotients, if you will. So at this point, I have 40 divided by 4, which is 10, and 16 divided by 4, which is 4. And so my quotient then is 14. In 4th grade, when working with decimals, so students would be introduced to a problem similar to this. So 28 and 4/100ths divided by 4. So if you think back to division of decimals using that long division algorithm, problems like this often students would forget about that 10th place being a 0, and they might miscalculate because there's so much around, lining things up correctly, and all of that kind of goes along with teaching that procedure. But if we can teach students to decompose numbers by place value in order to divide, then a problem like this becomes very simple. So 28 and 4/100ths can be broken apart into 28 and 4/100ths. And notice I wrote that in word form because we want students to apply their understanding of multiplication and division of a whole number then to decimals. So in this case, 28 divided by 4 is 7, and 4/100ths divided by 4 is 1/100th. And so we wouldn't make that mistake and accidentally put that 1 in the 10th place. So then 7 and 1/100ths would be the quotient. Okay. So along with all of that number sense, problem solving, again, is really at the heart of the curriculum. And this is one of my favorite quotes from Dr. Yep Bonhar, who was one of the original contributors to the primary mathematics series that that Singapore used when their students were really rising to the top. He says, we're not teaching math, we're teaching thinking through the medium of math. So really what we're teaching our students are to be able to problem solve and to critically think through things and to see connections and to look for patterns. That's really what mathematics is all about. So bar modeling is a tool that is used with a Singapore style curriculum to help students visualize problem solving. It's a tool. It's not meant to be a chore, although many students look at it that way. It really is meant to be a tool to help them access the problems. It's a great visual model for fraction word problems, ratio problems, percentage problems. It really helps students come up with a plan to solve the problems and to determine what operation they need to use to solve it. It's leading students into using the algebraic method, and it actually is developing a visual so that when they get to algebra, all of those algebraic expressions make sense to them because they have been visualizing this all through their elementary education. And this one's the kicker here. It provides access to challenging problems. Thinking back to the Trends in Math and Science study, when we looked at those different benchmarks of questions, that big gap that was in the advanced level questions between Singapore and the United States, Singapore actually has more than 50% of their student population in fourth grade who can answer challenging problems. And it's because they understand how to use this tool of bar modeling. So it gives them access into these multi-step, unfamiliar, challenging problems. So just going to do a little quick bar model boot camp for you guys. So there's really only two types of bar models. There are part whole bar models, and these are used when if you're given the parts and you're asked to find the whole, or maybe you've been given the whole in one of the parts and you're asked to find the other part. Okay, so it's any time that we're putting parts together or taking those parts apart. So here's an example of one. Sally bought some chocolates. She ate half of them and gave some chocolates to her best friend. She had some chocolates left. How many chocolates did Sally buy? So remember I said that strips of paper would be really helpful for students. So imagine that you gave your child a strip of paper and you said, okay, I want this to represent the box of chocolates that Sally bought. Can you show me what half of that looks like? Right? Then they can fold it and they can write on the strip of paper and they can say, these are the ones she ate. So they can start labeling right on this. Now, you probably are wondering why there aren't any numbers other than knowing that she ate half of them in this problem. That is a great strategy to get students to visualize the situation. So if you pull the numbers out and you really just focus on the situation, that's honestly, truly what's most important. I was at, it's probably going on 5, maybe even 8 years ago now. I was at a math conference and the speaker said, the numbers are the least important part in a word problem. And it was one of those like just aha moments. And it's like, you know what, you're right. Because if I can draw a model of what I need to do to solve this, I can put any numbers in there and I'll be able to solve it. So the numbers really aren't important. The situation is what's most important in determining what process or what I need to go through in order to solve it. So there's your numbers. So Sally bought some chocolates. She ate half of them and gave 7 chocolates to her best friend. She had 5 chocolates left. How many chocolates did Sally buy? So we want students to go from, again, from that concrete model to drawing the bar model. So this would represent the whole box of chocolates. Now, for parents, what I usually say is if your child comes home and they say, my teacher says I need to draw this bar model, but I don't know what to do. Can you help? What I recommend is that you say, just draw a bar on your paper. So 9 times out of 10, if you can just get them to draw a box, a long skinny box, then it gets them over that hurdle, because we could draw that box and then you could say, okay, what do you want that to represent from the story? And in this case, gosh, could it represent the half that she ate? Sure, we just have to draw another half equal sized, right? Could it be all the chocolates? Yes. So just getting them to put something on the paper and then to decide how they want to label that. So in this case, I'm going to say it's the whole box. So I know she ate half, so we'll divide that in half and label. That's what she ate. And then with the rest of it, it says she gave 7 chocolates to her best friend, and then she had 5 chocolates left. So out of the half she didn't eat, she gave away 7, and she had 5 left. And what we're wondering is, how many did she buy? Now that we have this nice visual, we can then come up with our equations that we could use to solve it. So in this case, maybe we add 7 and 5 first to get 12, and then somehow double 12, either multiply by 2 or 12 plus 12 would be 24. Okay. So that's a part, whole bar model. And then there's comparison models. So these are those word problems where you might hear fewer than, greater than, more than, less than, things like that. It's anytime we're comparing 2 or more quantities. And so what you'll notice that's different about this is that instead of those bars being side by side, they're stacked on top of each other, because what we want students to start recognizing is that at this point, the value of those 2 are exactly the same. This part right here is what we would call the difference. So this extra part over here is our difference. So that might be how many more than, how many fewer than, how many greater, how many less, how many more, those kinds of words might come up. So here's an example of a comparison word problem where multiplication is playing into effect. So Julia had 3 times as much money as Alex. So that's kind of our situation, right? That's what we want students to build. Post-it notes are great equal-sized units for students, and they kind of love working with post-it notes. Cubes, squares, anything like that that are equal-sized units would be helpful to model this physically. So Julia had 3 times as much money as Alex. So we want to visualize that first. They have $48 altogether. We're wondering how much money Julia has. So what we can see here is that they're all together, the $48 is represented with 4 equal-sized units. And so then we can use that to help us figure out the value of 1 unit. So 4 units is 48, then 1 unit is 48 divided by 4. Now, remember we talked about how this really helps students to visualize that algebraic method? Are you seeing that here? Like, could we say that, each one of these is an X? And so we could start thinking through this as 4x equals 48. We're trying to find 3x, right? So 3 units would be 12 times 3 or 36. And so students are being exposed to problems like this from about 3rd grade on up. So they're practicing this, they're visualizing this, so that then when they get into algebra, they're just replacing these boxes with X's or other variables. So Julia then has $36. Okay. So we start here. We ask students to learn how to bar model addition, subtraction, multiplication, and division problems so that they understand how to use the tool, so that we can get them to where they can use the tool for fraction word problems, ratio word problems, percentage, and those challenging problems that students will face in their mathematical careers. Okay. So this is one of my favorite problems. So this kind of demonstrates maybe a little bit more of a challenging problem, if you will. So we're talking about ratio now. So a ratio is a comparison using equal-sized units. So the sides of a triangle are in the ratio of 3 to 5 to 7. If the perimeter of the triangle is 90 centimeters, find the length of the shortest side. So we're thinking equal-sized units. So we're going to compare the length of the sides. So one side is 3 units to 5 units to 7 units. The perimeter of the triangle is 90. So that means if we add up the value of all those units, it should total 90. Okay, we're looking for the length of the shortest side. So now visually, we can see that all together, we've got what? 15 units. And so if we know that 15 units has a value of 90, then we can figure out the value of 1 unit. Now, a lot of students will stop right here and they'll say that the answer is 6. Remember thinking back to those problems on that Trends in Math and Science study that I showed you. They'll stop because they've solved something and they think that they're done. But by visualizing the problem solving with a bar model and putting that question mark on there, if I look back at my question mark, then I'm going to think, well, wait a second, I'm not done yet, because what I just found was just the value of 1 of those units. I still need to keep going because the shortest side is actually made up of 3 of those units. And so then 6 times 3 is 18. So the length of the shortest side in this case would be 18 centimeters. Now we start here so that students can start making that connection between this visual model and the abstract math that we want them to do eventually. Okay, so we don't stop here. We do get students to working with ratio in a more abstract level eventually, but this is where we start with them. Okay, and again, think about the students who maybe struggle with memorizing procedures or struggle with the abstract. This provides access to all students into problems, these rich problems like this. Okay. Because we want students to get to a point where they can answer problems like this. So I've shared this problem with parents, and I've had parents say to me before that there were a lot of problems similar to this on the LSAT that they had to take to get into law school. And that they were saying that, gosh, they wish they had learned how to bar model. Madison started saving some money on Monday. On each day from Tuesday to Friday, she saved $2 more than the amount she had saved the day before. She saved a total of $60 from Monday to Friday. How much money did she save on Monday? So this is a pretty high level problem, but I would argue that a 3rd grade student who has a firm grasp of bar modeling and can use that tool effectively can draw a model to solve this. Okay, so what do we know? We know she saved some money on Monday through Friday, right? We don't know that amount, but we know that she saved some money, right? So we know she saved on Monday, and then each day beyond that, she saved $2 more. So she saved the same as she did on Monday plus $2. And then on Wednesday, the same as she did on Tuesday plus $2. Thursday, same as Wednesday plus $2. And Friday, same as Thursday plus $2. Now, I don't really know how big those units should be because I haven't quite figured out the totals yet, but this gives me a visual into the problem. So what I know is every one of those little blue outlined boxes has a value of $2. And I know that altogether she saved 60. So I can count up all those little blue boxes and see that there are 10 of them. And if each one of them is $2, then that's a total of $20 right there. So then I can remove that from my problem. I can take that away from the 60. So 60 minus that 20, if I remove all those little units there, leaves me with $40. So now I have 5 equal sized units that have a value of 40. Is the math hard at all? No, it's the problem solving. It's visualizing it. That's the hard part with this. Okay. 5 units is 40. So then 40 divided by 5 is $8. So she saved $8 on Monday. Okay, so here's where we want them to be able to go with this. We want them to really focus on the situation when they're solving problems and being able to represent that with a picture or a model in order to help them access the problem. Okay, so how can you guys help at home? Be super excited about math. You know, math may not have been your favorite subject, but we want to make sure that we feel the excitement around this, you know, the excitement about how they're learning math now and how it might be different. And that's okay, you know, that they're learning something in a different way than you did. Be supportive. So, you know, your child might come home and say, we learned this different way of math. It's different from how you do it, and I don't remember it. And everyone's going to get really frustrated at home. And it's super tempting to just say, hey, you know what? Let me just show you how I learned it. unfortunately, when that happens, what your child might hear you actually saying is, your teacher doesn't know how to teach math. Let me teach you the way I did it. My way is better. And so what I would ask is that when a situation like that comes up, it is absolutely okay for you to just say, you know what? I don't understand the way that your teacher's teaching it either, but I would like to know. Would you go back tomorrow and tell your teacher you didn't understand it, and then have them explain it to you, and then come back and share it with me, because I want to learn this new way of learning math too. Okay, so be supportive of what's going on in the classroom. You can also help at home by helping help your child meet these basic benchmarks for fluency. So in kindergarten, have your child play with lots of numbers, count lots of objects, put numbers together, take numbers apart, just talk about numbers in your everyday life. By the end of the kindergarten year, help your student be fluent in adding and subtracting within 10, so that they get into first grade and they're ready to go. They've got those addition and subtraction facts within 10 set. So at the beginning of first grade, we really do want students to be strong with addition and subtraction within 10. By the end of first grade, they should be able to add and subtract within 20. So sorry, this chart is a little bit, it looks a little wonky here. I think the handout that I gave you explains it a little bit better. Usually I do this presentation at the beginning of the year. So with this being midway through the year. So think of these as, this would be a beginning of year benchmark for first grade. This is a beginning of year benchmark for second grade. So by the end of second grade, we want them multiplying and dividing by 2, 3, 4, 5, and 10. Okay, that makes sense. And then by the end of third grade, they should be multiplying and dividing by 6, 7, 8, and 9. So if you currently have a fourth grader, you can help them multiplying and dividing by 6, 7, 8, 9 if they're not fluent in that yet. If you currently have a third grader, start with 2, 3, 4, 5, and 10 if they're not fluent there, and then build on the 6, 7, 8, and 9. Okay. You can also play games, and this is one of my favorites. And you know what? Let me stop the share for a second, because I think I have to share my sound. Okay. Normally, if I was in front of you guys, I'd have you come up and we'd demonstrate this game together. So this is a card game that you can play. It's called Salute. And these are my little paper plate friends that are going to show you how to play the game. So Sally, if you can just give me a thumbs up if you can hear it.
This is the game of Salute. It's a great game for practicing basic fact fluency in addition, subtraction, multiplication, and division. To play the game of Salute, the materials you need are a deck of cards. These Uno cards are great, just take the skip and reverse cards out. You could also play with a regular deck of playing cards, just take the face cards out, or if you happen to have a set of number cards in the classroom, you could use those as well. So you also need 3 players, player 1, player 2, and then the dealer. So to play addition and subtraction version of this game, on the first round, the dealer is going to deal each player a card. And then when the dealer says salute, each player flips their card away from them so they can't see it, and they place it on their forehead. Now player 2 can see player 1's card, and player 1 can see player 2's card, but they don't know the card that's on their own head. Then the dealer is going to say, the sum of your 2 cards is 9, and then the player who can identify the number on their own forehead first wins the round. So if player 2 says 4, before player 1 says 5, player 2 wins the round. And then the cards can go back in the pile for the dealer, just back in the bottom. And then at the end of every round, players could rotate positions. So player 2 would move into the dealer's position, the dealer would go into player 1's position, and player 1 would move into player 2. That way everybody gets their practice with addition and subtraction. Now to play this game to practice fact fluency of multiplication and division facts, games set up the same way. The dealer would deal a card to each player. When the dealer says salute, those cards are flipped to the forehead. Except this time, the dealer says, the product of your 2 cards is 63. And then the first player to identify their own number again would win. So that's the game of Salute, a great game to practice basic fact fluency in your classroom.
or at home. Okay, these are a couple of my favorite sites also for practicing. So basic fact fluency, I love Math Playground. There's lots of games on there. They're engaging for students. They also, Math Playground also divides it up by grade level, and it does pretty much correlate with the primary math curriculum. So that's a good place to go. Just, you know, if your child likes playing games online and you don't mind them doing that occasionally. For some extra problem solving and bar modeling practice through Math Playground, there's a part of Math Playground that's called thinking blocks. That is my absolute all-time favorite problem solving program or application. It's also available in app form from the App Store. It works on larger devices though, so I don't think you can find it on an iPhone, but you could find it on an iPad. So it's in the App Store for the iPad. Okay, here's what it looks like. So this is thinking blocks in action. You can see here where students would be given a problem to solve up here at the top, and then they can click and drag things in order to work through that problem. I'll turn the sound off on this one because it's not saying anything, but I'm just kind of showing you the tool here. So this is available again through Math Playground or in app form. I think there's 4 different apps. There's an addition, subtraction, a multiplication, fractions, and I think ratio problems. So, you know, if you'd like a little extra practice with bar modeling, or you feel like, you know, maybe you're looking for something engaging for your child to do when they are having some screen time, this would be a great place to look for that. Okay, it does give feedback, it gives support along the way. Okay. All right, enough of me talking. Does anyone have any questions for me or any comments or anything that I can help you with?
Great. Yes, if anyone we want to invite, I do have a question in the chat as well. And I don't know if you wanted to unshare at some point so we can have everyone on the screen. That's great. And Beth, thank you so much for this amazing hour. And now we can hear the voices of the parents who are with us. I do want to jump in with Joe's been super patient. Joe, sure, you could come in if you want to elaborate. A parent asked if you could speak again a bit about when geometry and logic are introduced. I could speak a little bit around, you know, our scope and sequence, but Beth, I thought you could, you know, start with that.
Yeah, geometry starts, oh my gosh, it starts in, you know, it does in kindergarten when students are working with shapes and patterns and looking for, you know, connections and things. I would say that a lot of, you know, what we remember about geometry and proofs and things like that is kind of embedded in the curriculum as well. I mean, students are exposed to, you know, explaining their thinking and why does it work and connections and things like that throughout. So as far as like formal geometry, I mean, it's embedded in every single grade level throughout. And so the scope and sequence, you know, it's a little after 10 p.m. here. I can't think off the top of my head, but other than to say, you know, students are introduced to different shapes and recognizing shapes and attributes of shapes. That goes all the way up through 3rd grade, identifying shapes and categorizing them. And then that moves into, in 3rd grade, they're introduced to angles. So that comes up a little bit. And then in 4th grade, you know, they're working with volume and area and perimeter and shapes and angles and finding, you know, all connections in that way. And then it continues to just grow from that. So hopefully that was helpful.
Yes. Any questions or thoughts? I was just wanted to you know, iterate. I mean, walking through our La Scuola classrooms, I was in a 2nd grade classroom yesterday and a 3rd grade classroom, and this is so very consistent with the day in the life of a child at La Scuola. And one aspect of Singapore math, Beth, is you spoke a little bit around this idea of estimating before, say, we're in a problem and it's not these round friendly numbers. And there's this encouragement to estimate. And with that estimation process, when they reach the other end, they have their result. they can ask, and this I feel like is signature Singapore math, which is it reasonable? And I see it in third grade, is it reasonable? And we're asking them, they've done this estimation, they've gone through all this work, and then they come back to their original efforts. So I wanted to share that and echo what you spoke about it as well.
Yeah, absolutely. I mean, that's, again, getting back to all those mental math strategies and developing that number sense is to get students to check their answers for reasonableness, to really start getting them to think about the numbers and what they're doing to the numbers and how that affects the numbers and what would be a reasonable estimate. I was in a fourth grade class today, and they were working with fractions, and they were comparing having to subtract, I want to say like 11/12 from 5 3/4. And a few of the students were coming up with numbers that were just, like way too small. And, I said, they were coming up with 1/12 as their answer. And I said, is that even reasonable? And they looked back and they're like, no, it wouldn't be at all, because if I had 4, so we want them to really start thinking about that, and to not just putting an answer there because they think they went through all the steps and they got to this answer, but then to look at that answer and think about where they started and where they, what they did to those numbers and what came out, and is that reasonable, so that they can catch those mistakes when they do make them.
Others, questions, curiosities, observations that you see at home or your children?
And feel free to just unmute yourself and shout out too, if you'd like. I thought I'd jump in one more time, just again to speak to a lot of what Beth was saying. With mathematics, sometimes there's this feeling it's only numbers. And really with the Singapore math program, we really understand that language is a huge part of mathematics. And so it's through these number talks or the dialogue. La Scuola is social, we highlight social constructivist classrooms. We want to hear the voice of the students and the diverse interpretations, so they can connotate whether I'm discussing a book I'm reading or discussing a question I'm trying to solve. They're tapping these strengths, and so it's not as if there's some mysterious capability in math. It's language based, and their symbols make it efficient. So I think we do see that, and I think that builds the excitement and the feeling of participation in math, because Singapore math, has a focus on the language. Mm-hmm.
Oh, I see Stephanie. Are you muted? No, you're not. Can you hear Stephanie, Beth?
I can't. No.
How? Let me see. That's right. Maybe I'll mute and unmute you. It looks like you're unmuted here, Stephanie. Do you want me to try that? Mute. Now ask to unmute. Here we go. Sorry about that.
Stephanie, go ahead and type it. Yeah, type it in the chat.
Okay. So we'll be wrapping it up in about 10 minutes. If anyone really wants to, I know we're already into an hour and 20. We wanted to design it to have a presentation and then have this open dialogue. Okay.
Yeah, don't feel like you have to stick around too.
Well, here we go. Here's Stephanie. Do you ever do the old-fashioned drilling down of the multiplication tables, etc.?
Oh yeah. There's a lot of gosh, right now there's a lot of discussion around multiplication and memorization of multiplication facts, and especially out where you guys are, there's a lot of more resistance to asking students to memorize their basic facts. I think that what you'll find with the Singapore approach is strategies will be taught to help students to understand the facts until they can recall them from memory. So memorization for the sake of memorization, you won't necessarily see in the curriculum. You'll see students introduced to strategies first, so that they can apply a strategy until they can recall it from memory. So I kind of equate it to, I feel like anymore, I'm probably dating myself by saying this, but when I was like in second or third grade and I made a friend at school, we would swap numbers so that we could get together and have a play date, right? And my friend would write their phone number down on a piece of paper. And when I went home, and if I wanted to call my friend, I had to dig through my bag and find that little piece of paper and pull it out, and I dial their number, right? Maybe the next day or the next week, if I wanted to do it, I had to pull out that piece of paper again and dial the number. By about the fifth time, I didn't have to pull out the piece of paper anymore. I could recall it from memory. So that piece of paper was my strategy. I used a strategy, I used a strategy, I used a strategy until I didn't need to anymore because I could recall it from memory. So that's kind of the Singapore approach to memorization of facts, is we want to give them those strategies until they can recall it from memory. So yeah, there's a lot of value in being able to recall those facts quickly from memory and with fluency. Because if you think about it, by the time we get into fourth grade and we're working with fractions and we're finding factors and multiples and common denominators, for the student who doesn't have that ability to recall those easily from memory, is really using a lot of extra brain power to try to access problems like that. So there is a lot of value in that, and with the Singapore curriculum, what you'll see is that, a lot of that practice to recall this from memory is done through games. So lots of games are played in order to just to solidify that memory of those facts. So if you're interested in learning more about games, I highly recommend that you reach out to your child's teacher and just ask for some games that you can play at home that make it a little bit more fun, because gosh, I can remember crying in third grade with flashcards, right? So ways to make it a little bit more fun, definitely.
I do see a question from John. How do you help kids develop the repertoire of strategies to decompose problems?
Ooh, it's lots of practice in the classroom, lots of sharing of different strategies. I think that probably, even as I was going through some of that right there, we didn't share a lot of different strategies, but I think that we all kind of have sort of our favorite strategy. It's just the way that our brain kind of approaches problems. And so your children will also kind of gravitate toward one favorite strategy. And so, the Singapore approach doesn't necessarily require that they learn or master all of these strategies, but just that they're exposed to them and they see different ways, so that, if they find something that clicks with them, we still want them to see something else, because maybe they'll see this other strategy and then realize, oh, wait, that's a lot more efficient and I like that one better. I used to explain it to my second graders as, you might have your favorite strategy, which is a lot of them, they just wanted to count on. You might find that's your favorite strategy. I want you to think about it like vegetables. I said, you love corn, right? And mom and dad know if they cook corn every night and put it on your plate, you're going to eat it. And then one day mom gets crazy and she says, I'm going to cook asparagus. And what does mom say to you? And they all look at me and they go, try it. You might like it. It's like, yes. And that's exactly what all these different strategies are. I want you to try this different one, because you never know until you try it, you might like it and it might be a better and more efficient strategy for you. So that's kind of how it's approached in the classroom. Teachers aren't asking students to memorize or to master every single strategy. And quite honestly, and this is what I share with teachers often too, is it's mental math. You don't know what's going on in their head. But if they have a strategy that works for them and they can use it efficiently and accurately, that's what we're looking for. Right.
Thank you, Beth. We have time for, oh yeah, please unmic, please. Thought someone was going to unmic in this week. We have time for one or two more. Yeah, to your point about the repertoire, just if you're saying that in the classroom, you know, as we're solving something, we'll ask a student, you know, we have 3 choices of strategies or 4 we've just discussed. Which one are you going to take first? What do you prefer to, and how are you going to solve this? Select which one. So there's this conscious decision around that, but there's a familiarity across.
And there's also a discussion often in classrooms around efficiency of strategies, because you know, some of the strategies get a little complicated, and you know, you're adding and subtracting and doing this and that to the numbers, and then some strategies are a little more streamlined, and so there is that discussion of efficiency and strategy as well.
All right. Well, with that, one more huge thanks to you, Beth.
Oh, you're welcome.
Such an informative evening and inspiring. And thank you to everyone here. And we look forward to speaking more about math. And any questions, I will be sharing the handout that Beth sent when we send out the recording. And of course, I'm an email away as well, or any of your teachers, of course, because they are experiencing it and inspiring the children every day. So thank you so much.
Thank you all so much for coming tonight.